Well, it says go on my end, I think.
Yeah, another 10 seconds here.
And I've got another 30 seconds here on the YouTube side.
Crockies. Jeez. And it's go.
Yeah, I've already got the go in the OBS, but YouTube's 30 seconds behind.
Oh,
Crockies.
30 seconds is about average, isn't it?
Yeah, I'm usually 15. Average
Okay.
average is 15. So I don't know why I'm a bit slow tonight. I wonder if it's because of the heat or something. It's got anything to do with it.
Oh, it's a fun night.
Oh, well, that's your lot for tonight. See you next week. Bye.
There. Yeah. How to do technical difficulties.
Okay. See, mute. If you say my name wrong, you spell it wrong. Yeah, 15 seconds is usually my end as well, but for some reason it's at 30 seconds tonight.
I'm, uh, I'm going to do what Surf asked. So
What's that?
this is a timing test.
How do you do that?
I've just done it.
Ah, so when you typed it and then said it,
Yeah, I said it at the same time they enter, so they'll see it come up on the thing,
yeah,
and then they will hear my voice and be able to estimate the timing delay.
okay. Yeah, the only way I can do it on my end is when I have the timer going in OBS and then I see it out in YouTube.
Yeah.
See, at the moment I'm lagging behind
Okay, so that was
24
only like 15.
seconds to
That was
me.
like 15
Yeah,
seconds to surf. So
right. Yeah, well, even on my YouTube, I'm lagging behind on the little slider thing. I've got to press the live thing for it to catch up. And I haven't changed the settings in because they usually stay the same in the studio for each stream.
yeah,
I don't change that low latency, high latency stuff. It usually just stays. I haven't touched that one.
yeah.
I'm
I
just
mean, I've
wondering. I'm just wondering if it would have, but I couldn't see it doing it on its own, changing.
yeah. Um,
Interesting. But this is the same settings as last time. So whatever our last, yeah. So we're using the same settings as what we had the problems with. So I might have to go in there and just double check to see what it's using in case I've clicked it accidentally. But it's usually down on the left side, so I don't usually click anywhere down there. Well, I'll double check it. There you go to stream. Go to stream settings. Let it load.
yeah, I'm seeing, I think, about a 30-second
Okay.
delay.
What's it saying here? Error. Duplicate stream key. Select a new stream key. No, it just says normal latency. That's what I usually have, I think.
Yeah, the stream is good, Terry. So
Yeah, I don't remember clicking that to change it to low latency.
Yeah, well, your YouTube is probably not keeping up because of your internet, but the stream is good. So,
Okay.
we can probably think about starting the show, can't we?
Yeah, I know. It doesn't feel right, does it? But I'll grab that document and find it again. Where did I hide it? Stream topic. Now, which one?
Hey, right, Terry.
Which one were you going
The
for?
show must go on.
Which one were you going for, Alan? The
Well,
document?
I was going to go with the MagLab one first, and then the
MagLab, right?
Radio Fidelity one.
Radio.
That's the. I think that's the first, and I think it's the first.
The second. Yeah, the second one's the Radio Fidelity. Medium, they call it.
Yeah, that's it. Those first two.
Yeah, I got that. Radio Fidelity and MagLab 1. Okay. Yeah, I'll still have to screen share it in here, so the guys in.
Oh yeah, but yeah, if you screen share it and scroll as I read, but I can at least.
Yeah, you
keep
have
the
your.
scrolling
You've got
going.
your. Yeah, you're going to have your own thing. So.
Yeah.
Okay. As long as I can get to that. Oh shit. Find the right one now. All my OBS settings are all out too, so I have to find the right Google Chrome thing. Right. So that's that going. Now you want a full Chrome window, you want that. Right, now I've got the MagLab one up for the peanuts. And it starts off Marconi Radio 1897. And I follow you as you read.
Excuse me.
Jeez.
Sorry, I should have warned for headphone alert. I do apologise. Are we ready, Terry?
I don't know. Are we ready, Peanuts? Are the Peanuts ready? No, we had to wait 30 seconds for them to respond. That's going to be. I can't do that. That's terrible. I think they're ready.
I think they're ready. They better be ready. Right. Okay. Marconi Radio, 1897. A number of distinguished scientists had a hand in the discovery of wireless telegraphy, but it was the work done by Giulio Marconi that is credited with providing the basis of radio as we know it today. Numerous researchers and scientists played key roles in the development and advancement of wireless telegraphy, as radio was known in its infancy, including such celebrated names as Tesla and Thomas Edison. But the system put forth by Marconi was the first to be widely used. Towards the end of the 19th century, it was becoming increasingly evident that wireless communication was possible. A number of theoretical breakthroughs of that era led directly to the high-tech communication systems now used around the world. Marconi developed a means of transmitting a signal great distances and eventually commercialized a practical system. In 1897, the London-based company headed by Marconi opened the first wireless factory in Chelmsford, England, with a staff of approximately 50 employees. And it's still there, by the way. Over the next 2 years, he made 2 wireless transmissions across water to islands, leading to a major milestone in 1901 when he received the first transatlantic radio signal. That historic development took place in the northeast Canadian town of St John's, Newfoundland, with the help of a receiving antenna that was carried several hundred feet into the air by a kite. News of this development came as a shock. Most scientists thought that a radio transmission could only travel in a straight line, unable to bend with the curvature of the Earth. The signal was sent with a frequency of roughly 500 kilohertz. It was going to be a very wide band signal though, and a power boost far greater than had ever been used on a radio signal. The historic first message was 3 dots, Morse code for the letter S, a successful test that marked the dawn of the radio age.
Yeah.
Marconi's system had the following components: a basic oscillator comparable to the model designed by Heinrich Hertz, a capacity area positioned above ground level, a receiver to detect radio signals, a telegraph key to transmit Morse code, a telegraph register to record the Morse code on a roll of paper tape. After his history-making transmission, Marconi made swift progress. By 1902, his equipment was consistently receiving lengthy messages at distances of more than 1,500 miles at night and 700 miles by day. Just a year later, the Marconi Company was regularly transmitting news stories across the Atlantic Ocean. Besides developing the technology that made radio commonplace, Marconi helped shape the history and role of this powerful new medium. It was not long before literally hundreds of programs crackled across the airwaves. Marconi invented an entirely new science-based industry, largely through his persistent style and inventive thinking. A complex branch of physics became a consumer product that profoundly influenced the early 20th century and continues to evolve its influence in today's culture.
There is some facts that I want to bring up after reading that about to do with the signal strength and band, but I thought we'll talk about that later on, because that does make its presence known later on in the early 1900s to do with certain events that took place. So I'll tell you about that later, but if you bring it up, I'll tell you to shh, because I know a little bit about something that I was reading about it. Okay, and you want the other one now?
Yeah, can I have 30 seconds maybe before I have to start reading?
Yes,
I'll be
you're
back in just
fine,
a
you're
tick.
fine, you're fine. Yeah, don't tell anyone about saying about the curve. Nathan won't like that. Hey Phil. Yeah, we had a few technical hiccups. I don't know what's going on tonight. It's a bit slow for some reason. I reckon it's the heat. I'll blame something.
Back. Right. You ready then, Terry?
Yep, I'll grab that for you and share it in here. And I'm supposed to do it out there for them first. I mucked up. Oh, that's okay. It worked. Scroll down. Oh, here's a picture of Guglielmo Marconi.
Guglielmo Marconi.
I try to pronounce his name. Inventor della radio. I think that's Italian for inventor of the radio or something. There we go. Marconi and the history of radio is where I'm on now.
Yeah, lovely. Okay then. Long before we ever saw the likes of Bill Gates and Steve Jobs in the technology world, there were already innovators building the evolutionary ideas we still use to this very day. Marconi was an Irish-Italian inventor credited with being one of the initial inventors of radio. Without #Marconi, we might never have created the baby monitors, smartphones, GPS signals and other essential tools we use today. Marconi transformed the world by exploring the true potential of radio waves. He spent years improving the quality and reliability of communication tools and helped to inspire the wireless revolutions that we know and love. The story of Marconi is a complicated one. It is the tale of a 22-year-old innovator who was far beyond his time, yet unappreciated in his homeland. Here is your introduction to the man known as the father of radio. There are many people involved in the history of radio, from Heinrich Hertz to Nikola Tesla. However, the man most commonly associated with the invention of radio waves is Marconi. Born in Bologna in Italy, Marconi formed the foundations of shortwave wireless communication, the technology we still use in many modern applications. From an early age, Marconi pursued his love of science with the help of many different mentors, including physicist August Ricci. Ricci introduced Marconi to the work of Heinrich Hertz, James Clerk Maxwell and Sir Oliver Lodge. He also helped Marconi to build a lab in the loft of his family home where he would experiment with his own ideas about radio transmission and induction coils. Eventually, Marconi discovered a way to improve the quality and coherence of messages sent over long-distance radio waves. Using vertical aerials, he found that it was possible to improve the distance that radio waves could travel. He even tried to present his findings to scientists in Italy, though the innovators of his homeland were only impressed by his work. Unwilling to abandon his dreams, Marconi searched further afield for recognition and moved to London, where he received help from Post Office Chief Engineer Sir William Preece. With Preece's help, Marconi was able to file for his very first patent at the age of just 22. Throughout 1896 and 1897, Marconi showed his inventions to as many people as possible, attempting to prove the power of his transmission accessories. In 1899, he even installed his technology into 2 American ships so that they could report the results of a yacht race to New York City newspapers. Guessing that would have been the America's Cup. Why is Marconi the father of radio? Marconi is one of the most famous names in radio history because he was awarded the patent for improvements to radio communications in 1904, which prompted many people to name him the original inventor of radio technology. In 1901, Marconi sent the first signals across the Atlantic Ocean, and by 1910, he was introducing radio waves to the world that could travel more than 6,000 miles. In September 1918, Marconi sent the world's first radio message from England to Australia. However, Marconi's history of radio invention comes with some controversy attached to it. Although Marconi was commended by the Nobel Prize Society for his inventions and given various patents, many people still argued that Nikola Tesla was the original creator of radio. Tesla was responsible for creating the Tesla coil, a crucial component in the transmission of radio waves. Tesla originally designed his coil in 1891 and proved its long-distance transmission capabilities in 1895, I guess.
Yeah.
Why can't people get their articles proofread?
Yeah.
Years after Marconi originally received patent 7777 for the invention of the modern-day radio in 1943, the US Supreme Court eventually overturned the application, claiming that Tesla and other inventors were responsible for many of the methods that Marconi used in his systems.
Oh.
Yeah, well, damned Americans.
Yeah.
Yeah, shame Tesla didn't do anything with his inventions, though, isn't it?
Yeah.
To make them into a practicable system that of, that could be used by the world.
Isn't that like saying
Despite
the
this,
person that invented the wheel should take credit for inventing the car?
uh, despite this, whether you come down on the side of Marconi and Tesla, I bet you can guess which side I come down on. It's difficult to ignore the impact that Marconi made on the history of radio. Not only did he help to create the shortwave wireless communication system, but Marconi pushed to have his invention installed in countless ships and companies around the world. Without Marconi's dedication and commitment, who could say where the radio industry would be today?
Mm.
Did Marconi change the world?
Would we still be
Marconi
using?
died at the age of 63 in 1937, but his work lives on. When Marconi died, a host of radio stations across the world fell silent as a mark of respect for the fallen inventor. In later interviews, Franklin D. Roosevelt also said that Marconi was one of the greatest sons of the Italian people. He likened the father of radio to other Italian prodigies like Galileo, Dante, and Michelangelo. While it is easy to take the concept of radio for granted today, before the 20th century, wireless communications were impossible. Marconi's experiments as an original inventor of radio made him a pioneer and an outcast in his world. A man ahead of his time. Marconi had a vision of a world where wireless communications could transform our lives and even eliminate the need for war. Without Marconi's radio inventions on the Titanic, it would have been impossible to rescue the survivors of one of the world's most famous disasters. Although Marconi's history has its dark patches, it's impossible to ignore the impact that this great man had on the evolution of radio. Today, his technology can still be found in the systems behind your Bluetooth speakers, smartphones, and GPS. To learn more about the history of Marconi, visit their website for a full biography.
Yeah. Yeah. The Titanic is an example of something that we'll talk about too. There's a bit of a
So,
story there about
can I just say to Sir, no, I'm not going to avoid saying his first name. It's too damn difficult.
that.
I saw that, but I didn't want to interrupt
Yeah.
my
Yeah.
reading.
Yeah. Marconi. It's easy to say Marconi. We'll stick with Marconi. Hmm. And that'll do that. Now, that video. So now I've got to go and find that video again now that you gave me. That I picked out of the list. You can explain when I get it. Find it again.
I just realised now I can shut those two tabs, so that's gonna help, isn't it? Shut them two tabs.
Now I've got to find it again. Where'd you put it? It's in that playlist. Now I've got to find which one it was.
I thought, oh, of course, you have to reboot your computer. That's why.
Yeah. Okay. Now the Marconi Spark one, is that the one you think we should play for now? Because that's the closest. Which one do you think out of them could closely resemble his basic system for sending? Because there's that one, and
The spark transmitter was the spark transmitter is the transmitter that Marconi was using in up more or less up until the war, and then until they were eventually banned in about 1920 because
and I know why. I know why.
Because they're not
Yeah.
pleasant.
Yeah. But would there be another one that shows it more basic of what he was using to start with, or would that be?
That is, I mean, that spark transmitter is about the most basic radio transmitter you can get.
And then what he would have, yeah. But what I'm asking is,
Yeah,
if that components
it's
that one shows is what he started with, or was it more simpler or different? That's what I don't know.
I don't know. I mean, a
That's what I'm
spark
trying to get
transmitter,
at.
a spark, Terry, a spark transmitter is a spark transmitter. They might have refined the putting together of it a bit, but the components of it are the same.
Right. Yeah, I was hoping to find something that showed like a replica of his first one that he used for like he experimented with. That's what I was hoping to find.
Yeah, I mean, generally the prototype stuff is put together in such a way that it's not necessarily superly practicable on a as yeah you when you make a commercial, when you start making it commercial, you try and make it as small as you get, as
Yeah, I
small
know
as you
you
can.
refine it and tweak
You
it
refine it,
so
but that
yeah.
won't be much. That there won't be much different to what Marconi actually was using.
Okay. Um, I think that's big enough, isn't it? Before I went to theatre play. No, that's no good. I'll leave it the other way. That's default view. Um, Everything's right on my end.
This is a Marconi spark gap transmitter from the early days of radio. And the way this worked essentially is that it's a big step-up transformer, and the telegraph key is a switch that turned it on and off. So when you close the contact with the telegraph key, a spark jumps across the gap between these two electrodes over here, like this. And this would also be hooked up to an antenna, so that would be spewing out radio waves across a broad spectrum of the radio frequency. The problem with these is that when one was going, the sort of strongest, loudest one was the one that could be heard, and you had trouble hearing all the rest of them. And this actually came up on the Titanic, because the radio officer on the Titanic was broadcasting messages from the passengers of the Titanic, which was a money-making operation for the Titanic and the Marconi company. And the Californian, a ship nearby, was stuck in the ice field and was trying to broadcast a warning about that. The Titanic radio officer asked him basically to shut up because he was trying to hear his relay station that was helping him broadcast his passenger messages. So the Californian radio operator complied, shut up, turned his radio off, and I guess the rest is Titanic history. So we'll just show you the spark again. Just a little technical detail about this. This is an important part of this equipment as well, too. This is the make and break hammer contact here. And it works like a doorbell, essentially. So when I turn the power on to the coil here, it creates a magnetic field which pulls this contact over this way and cuts off the power. So then that comes off back this way, turns the power on again, and it goes back and forth like that. So that pulsating magnetic field is what allows this to operate as a transformer on a DC source.
Hello, my name's Alvin, and in
Oh, was I muted? Shit. What was I saying? Oh, yeah, that video. that big black thing, is that, he said that was like, to me that's like a solenoid.
Yeah, it's
Electricity.
essentially a solenoid
Yeah.
that you're switching on and off really quickly. But it
Yeah.
is actually a transformer. But it is actually a transformer. So you've got the main coil, and then you've also got a secondary winding that takes the power off and steps it up,
Mhm.
like the coil in your ignition pack.
Yeah. And what electricity were they actually getting at the time to power it?
Battery.
Wow. Oh, that goes back
They
to our
power off batteries.
that goes back to our battery cars, electric cars thing, doesn't it? Sort of
Yeah.
ties together.
Um, yeah. You'd use a battery for it. Although, of course, you can plug them into. The thing is, you need a DC power source for it. So,
Right.
um,
Because AC wasn't really around much because of tests between the two AC/DC people that fought over the
uh,
power to use. Those two people too. That was a thing.
yeah, you mean the Edison Tesla thing over
Yeah.
DC and AC.
Yeah. Yeah. Well, AC won for powering houses eventually, so. Alright. Well, since we're behind schedule, we'll catch up a bit more of this on Wednesday. Um, got a little bit of derp here, so we'll play
Good.
that. We'll do we'll do a little quiz, and I did have a Pip story somewhere as well floating around. I'll grab that in a minute. Um, so I'll grab the dirt one. I've got uh, which two? Which two was it I had? I forgot.
I don't know.
I don't know. I forgot myself. I'm trying to remember. Scott posted in any other vids a Nathan Thompson thing. Now here it is. There's that. We'll play that idiot's thing. Pause that for a minute. Stop. Pause. Only goes for a couple of minutes. But I did want to play, after that, something that a person that's came back on the scene, I think, if I can find. Might be in Show Your Shit. I think Simon Dan dropped it. It's only recent. Oh, pardon me. Where is it? Can't find it now. Oh, here it is, I think. Yeah, that guy. That's the one. Right, so I'll play them too.
Yes, sir. Gate guy.
Ah, spoiler alert. Can't keep a
I don't know.
Can't keep a secret round here, can we?
I don't know. I was just talking to Surf. Like,
Yeah, but it's not your fault. It's probably Surf's fault then. Spoiler
yeah.
alert. Then, yeah. Dear, oh dear. You put it. Yeah, I know you did, Newt, but It's supposed to be in any other vids, otherwise you'll get into trouble. You put them in fair suck, somebody will go off at you. Unless you did put them in the right place, well then retract everything I just said. Because I can't find them. If they're in the fair suck, which is the chat, I won't find them. So, okay. And they have to be previewed before I can play it or known about. So, I do have somebody that's a secretary that usually helps me out with that sort of stuff, but he's been a bit AWOL lately, so. Alright, okay, we'll do that one first. Here we go. Share that. Use guys in here, so you know what we're looking at. And I'm sorry it's this person, but when a person's wrong, well, before we even play it, we know they're wrong.
Warning! In this video, we debunk the heliocentric fairy tale. If you have emotional ties to the globe religion, please keep that crybaby stuff to yourself. Thank you. So this is a video of me shining a laser through a glass jar that has an etched-in lattice structure at the top, and it looks very similar to the P900 and P1000 videos I've got of stars, which is the...
Whoa. Straight away. That's straight away something I can correct him on. Yeah, I even know where he's wrong with that one. Am I allowed to say it?
Yeah. Can I firstly say it'd be nice if you straightened the screen out that you're projecting it onto, wouldn't it?
Yeah.
Or that too.
I mean, I don't mind a little wrinkle, but you could, you know, I mean, don't have to iron it dead flat, but you could at least pull it out tight. Go on, Terry, tell us what's wrong with it.
I'm not going to say now, you interrupted me. Anyway, it's to do with when your focal or your zoom thing, to do with your camera or telescope. That's not the words I was going to use, but that's what I remember I was going to say something about. Something to do with focus or something. When you're looking out into the night sky at the stars or planets.
You mean it being out of focus and twinkling in the Earth's atmosphere?
Well, he's trying to make out it's the same effect looking through that as what we see, because he said it's his videos that he shows on his channel of what's up. People have taken the flurfers because they can't focus on the night on the planets or any stars or anything.
Yeah, because the P900 has this really nasty little problem. You can't manually focus and you can't turn the autofocus off.
Okay.
The video on the left, and I agree, it looks very similar to reflections underwater, but I also think it's incredible how similar it looks to a laser being shined through a glass jar. Now Ezekiel talks about the wheels within the wheels.
Shines? Is that
being shined. I think he means shone.
Yeah, I know. I think grammar
shine
not
is
good
usually
for
the
him.
past tense of shine.
Yeah, grammar not good. Sorry.
Yeah.
And the whole Bible mentions the layers of heaven or levels of heaven. I'm just wondering, maybe there's some type of layers to the firmament, and the stars are above the sun, the moon, and the planets.
Just
and that
out
layer
of focus.
is what's causing the twinkling
And
of the
maybe
stars.
there's not.
It also could be why during a partial solar eclipse, each individual shadow is an eclipse, which I think is incredible. Until now, I
That's
never
a cool
really
effect.
understood how that could
I've
work.
never seen that before.
In my opinion, now it makes a lot.
Isn't that the same effect when you put a bit of paper with a hole in it on another bit of paper tape type of thing.
Yeah, essentially you're getting pinhole camera effects from all the gaps in the leaves.
Yeah.
A lot more sense. Now the Glober's explanation for the twinkling of stars is this. Right here, a cartoon.
It's a big problem.
It says the gas above our head moves around. So we see this. Now, I don't know about you guys, but that makes no sense whatsoever and cannot be demonstrated.
That's not what we actually see.
What is the
That's what the
It's
camera's
a big
seeing.
problem. I mean...
Yeah, you got a big
Pause it
problem.
if you're going to talk, Terry.
Yeah,
Sorry.
See, you would see the star. You'd see the nice sharp point of the star wobbling around a little bit. If it was in focus.
If you could see that effect with your own eyes, you've got either good eyes or bad eyes.
Well,
One of the
Terry, everybody sees that effect when they go, because you know if you look up at the stars at night,
yeah,
they
but
seem
you don't
to
see.
twinkle.
Yeah, but
They
you don't see that
twinkle a little
define.
bit, don't they?
Yeah, they twinkle a little bit as a little dot, but not like that. Like the camera's got it out of focus.
Yeah. Terry, remember, the star is horrendously magnified, so
Yes.
the effect is horrendously magnified.
Magnified, yes.
But it's also, but the problem is that it's also out of focus.
Yes.
I don't get where they get off saying that, oh, he doesn't think it's due to refraction. I mean, we know that refraction is a thing in the atmosphere. Refraction is a thing anytime light passes through any kind of medium. So why wouldn't it change the direction of the light randomly? I mean, again, the atmosphere has random fluctuations in its density and temperature. Of course there's going to be reflection effects. It's just common sense. Oh, that's the problem, isn't it?
Yeah, and of course, that deep misunderstanding that autofocus doesn't work in very low light conditions.
Got it. And what makes a lot more sense is what you can demonstrate. Looks like a reflection underwater, or it looks like a laser being shined through a crystalline type glass or firmament structure. So they can't demonstrate it at all whatsoever.
Hang on just a second.
Those ones back. That one.
I thought. Oh no! It's the stars we're talking about. Because he suddenly started showing our star, and our star is, I thought, supposedly inside the dome. according to the idiots.
Well, it begs all sorts of other questions, doesn't it? Where's the laser being shone from? How is this laser being moved so that it appears that the stars rotate? You know, it's all sorts of things that, you know, they must be using different colour lasers, different temperature lasers, different sized lasers. The lasers seem to be capable of mimicking parallax between the stars. Yeah.
So they can't demonstrate it at all whatsoever. Happens all the time with these spinning ballers. But my next question is, if light coming through the atmosphere is twinkling, how come Jupiter isn't twinkling? You can clearly see Jupiter's moons, which aren't moons, they're stars assigned to Jupiter.
Because the size of Jupiter is big enough that it doesn't twinkle. It's got enough light coming from a wide enough angle that it doesn't twinkle. That's simply the explanation. That's all it is.
But Paul, I'm watching that bit of video and I am seeing Jupiter and the moons all twinkling. It's just that they happen to be almost in focus as well.
The other thing is, like, okay, so he doesn't think it's refraction in the atmosphere, and yet we can use adaptive mirrors to correct for the refraction. And we do that by shining a laser up into the sky and noticing how much it refracts and making the appropriate corrections in the mirror for that. And it works.
Yeah.
Twinkling,
but also you have to. What can I say? He'll say, yeah, but only big institutions can afford to do that.
Oh yeah, we can't do that. Only
We
NASA.
can't do that.
Only NASA can do it.
Because, you know, adaptive optics are quite expensive to run. But, you know, I'm pretty sure there's plenty of universities out there with that type of stuff.
So don't tell me this isn't in focus or not detailed. How come Saturn and Mars?
Well, I can see that twinkling.
How come the sun?
Exactly.
Look at it shimmering.
How come the ISS, ladies and gentlemen, is not twinkling? And in this video, you can clearly see a star twinkling as the ISS flies by.
So he's
Yeah,
he's confirming the ISS now.
But remember, the ISS is really, really bright.
Close.
So, well, that doesn't actually matter because it is still looking through pretty much the entire atmosphere at it. The point is, the ISS is usually really, really bright. I mean, you know, -2 to 3, even nearly to 4 on the brightness scale, which makes it very, very bright. And it is moving anyway, so
Yeah, that's right. You're not going to notice it twinkling.
You're not going to notice the twinkle.
Yeah, that's right. Again, the twinkling, what it boils down to is the angular size of the object that you're viewing. If it's got enough angular size, it won't twinkle.
Yeah, Jinx Yu makes a good point. The ISS is not a light source.
So what's the Glober's explanation for this? They're not going to have one. They don't have an explanation for anything. They just double
Of course we
speak.
do.
They have a religion of contradicting themselves over and over and over again. So thanks so much for watching, guys. Really appreciate it. Hit the like, share, subscribe if you're not already subscribed. More gravy to come later.
No, sorry. Settled it. Say goodbye to Nathan.
Bye, Nathan.
That was basically just, don't tell me what it really is. I think it's something far more unreasonable and unlikely than what it could be.
Yeah.
Okay, Fred's getting technical now. Stars also twinkle because of the effects of gravity on the light waves as they travel. Planets hardly twinkle at all. Okay, something completely different.
Without a doubt, the man that brought a lot of you to this channel was the Gate Guy.
Yeah.
I'm still confused with this guy.
Good. I didn't have a clue what he was supposed to be doing.
He seems to think that he's cracked it when it comes to the science of flat Earth, and he is back. This time, debunking the ISS. Hello all and welcome along to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Before we begin today, a huge nod to the Patreons of this channel who voted in a poll for this video by the Gate Guy to be included in today's Flat Earth Friday. If you'd like to get involved with this too, then please do check out the Patreon page. The link is in the description and there's plenty of rewards up for grabs. And of course, episode 1 of the Simon Dan podcast is out now. It came out on Wednesday. The first episode is just me and Katz having a chinwag about conspiracies. The links for where you can find that is also in the description. Right, back to today's video and Mr. Chris UK with his video, The Inconvenient Physics of the ISS. He genuinely thinks that he's debunked it. Let's check it out, shall we?
This is from the University of Colorado Boulder website. It's a gravity and orbit sim. Have a look. The link is in the description. We're looking at the orbit of the ISS. Remember, the Earth and the ISS are both travelling around the Sun at 67,000 miles an hour.
Approximately.
Yeah.
At this point, the ISS is travelling at 67,000 miles per hour with Earth, plus 17,000 miles per hour. Gravity off.
Oh, don't tell me
The
it's gonna
ISS
add
is
the
travelling
two
at
together.
84,000 miles per hour around the Sun. 67,000 miles an hour plus 17,000 miles an hour, as it was when it was orbiting Earth at the point gravity went off.
Just to point out here, there's often a very common misconception regarding the orbit of the ISS. So, to clear that up before we continue, the ISS is orbiting Earth at around 17,000 miles per hour relative to Earth. The ISS and the Earth are travelling together in their orbit around the Sun. When the pieces of the ISS were taken up into orbit, as they were building it, those pieces retained the Earth's orbital speed around the Sun due to the conservation of momentum.
At this point, the ISS is travelling with Earth at 67,000 miles per hour, or less, 17,000 miles per hour. Gravity off. The ISS is now travelling at 50,000 miles per hour around the Sun, as it was at the point gravity went off.
We must remember here, of course, that the gravity cannot be turned on and off like that, and that the Sun's influence over the ISS will be extremely small compared to that of Earth's.
67,000 minus 17,000 miles per hour.
Is this the same thing as somebody else brought up once before about how the Earth rotates at 1,000 miles an hour, and if you went the opposite way, you minus the speed or gain?
Yeah,
if you
they
went
get
the other way or something. It's the same thing, isn't it?
I've got a feeling he's going to say that the ISS has to speed up and slow down.
Yeah, that's what I was thinking a little bit too. Oh, okay, here we go. Massive acceleration and deceleration.
Massive acceleration and deceleration.
Yeah.
No, as I stated earlier, the speeds are relative. The ISS will not suddenly speed up or slow down as it leaves Earth's orbit, which it won't do, by the way. And again, the influence on the ISS of the Sun at this distance is so weak that it's almost negligible. Yes, a light in the sky that is moving. What is this absolute rubbish? He thinks the globe is broken, bless him.
Do you think this music's safe? I know Simon was playing it.
Yeah, just pause it for a moment there, Terry. He seems to have a misconception about this physics of rotation with translation. He just doesn't get it. I mean, the ISS being in orbit around the Earth, its acceleration vector, of course, is towards the centre of the Earth. That's what circular motion or orbital motion is all about, the acceleration vector being towards the centre of that orbit. Otherwise, it wouldn't be an orbit. So it's not changing its acceleration, so to speak. It depends on what frame of reference you use, of course. I mean, the acceleration vector is changing direction, but it's always towards the centre of the motion. So no, it's not speeding up and slowing. It doesn't have to speed up and slow down. He doesn't seem to understand that a change in direction is also an acceleration.
Yeah, and to take it to a simpler level, the ISS is also in orbit around the sun.
Yeah.
Yeah.
With the Earth.
And when it gets launched into space, it keeps its
But it'd still be it'd still be orbiting the sun.
it keeps the momentum from the fact that it was going round with the Earth anyway, doesn't it?
Mm.
Yeah, I mean, and he's right to some extent, as in there are minor perturbations to the orbit because of the gravitational attraction of the sun and the moon and anything else that might be nearby and stuff like that. Those things do have an effect on the orbits, but it's such a minor effect. But ultimately, it is the variation in the gravitational fields, even the gravitational field of the Earth itself, that causes these orbits to decay and for satellites to eventually come down.
Yeah, the gravitational effects of the Earth is greater on the satellites. Yeah.
Oh yeah, by far. But they do take advantage of the gravitational effects of the sun. I mean, that's what the Lagrange points are all about, where they do take into account the gravitational attraction of the sun as well as the Earth, and they offset them together in a way that makes the orbital period of the satellite be exactly the same as the orbital period of the Earth, even though the satellite is about 1 million miles closer to the sun. It still rotates around in the same period that Earth does, which means that the satellite can always be between the Earth and the sun. That's what one of the Lagrange points is all about. So they do have an effect, the gravitational attraction of the sun and the moon and stuff like that, but not so much when we have to calculate low Earth orbits and stuff.
I really don't understand your argument, Chris. Things in constant motion stay in constant motion, if of course they aren't affected by an outside source. So for all intents and purposes, they're effectively standing still. That is the real physics here, Chris. So that speed of 17,000 miles per hour of the ISS is relative to the Earth, whether it be moving constantly or standing still. How can you not grasp that? To top it off, the sun's influence on the ISS, as we've already discussed, is minimal. Gravity requires mass. The Earth and the sun are massive. The ISS is not. Look, the equation for the gravitational force requires two masses. You could figure out the gravitational pull between the Earth and the ISS and the sun and the ISS, and I can guarantee you that they would be quite different. Yes, it is. Yes, it is. I hope the answers I've given you here, Chris, are enough for you. I really do. If they're not, then you're welcome to message me over Twitter and we can hash this one out. Right, there we go. Another fantastic episode of Flat Earth Friday, done and dusted. Always love going back to the Gate guy. I've got a little bit of a soft spot for him for obvious reasons. I do hope you enjoyed it today. If you liked it, then please do drop a like on the video and subscribe as well if the feeling takes you. Again, a big thanks to the Patreons for voting for this video as well. I've been Simon Dan. Have yourselves a fantastic weekend and I'll see you all on Tuesday for a brand new Evolution video. See you then.
Yeah. I actually remember Simon Dan before Gate Guy went viral.
Yeah. Well, at least he's making something that we can work out where he's wrong compared to his gate thing, because I was still confused with that one.
Yeah. Gate was.
Who was that flat earther? It was Chris UK, wasn't it?
Yeah.
Yeah. Must check out his channel, see if there's any other dirt worth playing. I'm sure there is. I'm sure there's going to be.
Yeah. It'll only get worse or better. Better? Worse? One of the two.
Better? Worse?
Now, what did Mute been dropping stuff over in Discord? I just want to have a quick check out what he's been doing. What do you got? What have you been dropping? Oh, Irish Demon. Yeah, I don't. Oh, Reckless Ben. And I was like, oh, that goes for an hour and a half. I can't play that. Mute. What else have you dropped in there? Is that what you're talking about? Well, if you had a timestamp of something for that, yeah. I can't play the whole thing, the Irish Demon thing. Unless you've got it paused at that spot. Anyway. No, you'd need a timestamp for that, because I'm not going to play a whole hour and 39 minutes of that.
Right, is that all the dirt we've got, Terry?
Yeah, well, I was going to do Mute Donkey's one, but he didn't put a timestamp for the... because he said he dropped a video, and it's an interview with Reckless Ben about Nathan Thompson.
Okay.
Thing, so, and he...
Apparently Nathan Thompson comes in, but we need the timestamp for it.
Yeah. Sorry, Mute.
It's alright, we'll figure that one out next week, eh?
Yeah. You got some
while
homework.
you were asking, while you were asking about with your stream, Terry, I managed to actually create a presentation of media dirt. So.
Oh. I knew that. I knew that. That's why I was doing it.
it's only a little one, but it'll do. All right, so you want to see that?
Yeah, that's fine. I was going to say you might have even had time to have a quick blow through that video I gave you, even.
Oh no, I didn't have a look at that. I just,
okay.
Took an idea from it.
Oh, okay. I should have. Oh, well, okay. Well, that worked. That still worked.
Yeah.
I thought it might have helped you with something.
Yeah. All right. So it's a bit rough and ready, this one, but you know, who cares?
Yeah, who cares? That's one of those. It's one of those streams.
Yeah. Let's see if any of these rules applied in your household, hey Terry. All right. Here we go.
Make me laugh.
Here we go. Rule number 1. Here we go. My mum's strange rule was that I could never pet the cat because he shedded hair everywhere. One time I literally put my hand on my cat's head and my mum yelled at me so loudly and didn't talk to me for the rest of the day. I'm still really confused. I mean, even just putting your hand on the cat's head. I mean,
you get cat hair on your hand. But that's about all.
Yeah, but cats don't shed all the time. It's not that bad. I mean, you just get the vacuum out and
vacuum your cat. I mean, you vacuum the cat.
Well, no, you don't vacuum the cat. You vacuum the hair that's been shed.
Yeah, I'm going to say, if you're really that worried about animals shedding hair, why have an animal in the bloody first place?
Yeah, exactly. That's right.
You
probably could vacuum a cat. You probably could vacuum a cat, but you'd have to hold him down pretty tight. He's not going to like it. Yeah. Oh dear. All right. Number 2. We weren't allowed to leave the refrigerator door open for more than 10 seconds. There was a timer on the fridge and it would beep when it went past 10 seconds.
Yeah,
we kind of had a rule like that in our house too, you know, like you weren't allowed to just stand in front of the fridge and survey the contents of the fridge for, 5 minutes deciding what you wanted to eat. You had to decide what you wanted to eat by knowing what was in the fridge first. And then you just open the door, get it and shut the door. Because of course in the summer here it's pretty damn hot. Yeah.
I tell you, it really annoys me when my carers open the fridge door, take the milk out, leave the bloody fridge door open, put the milk on the side, then make the tea and put the milk in it, and then put the milk back in the fridge with the fridge door open.
Yeah.
Yeah, that's
but
a bit long.
I'm not allowed to yell at them for it anymore.
No.
So I just have to mentally struggle through it.
Perhaps they need to make a fridge that instead of pulling on a handle to open it, you press a button and it goes.
Yep.
And
I was
opens.
just thinking
Gives
the
you
same
10
thing.
seconds to take out what you want. Gives you 10 seconds and then the power closes, and be damned if you haven't got what you want.
Well, even one better, a remote control, so you could shut it remotely.
Oh, okay. Yeah. Yeah.
A person standing in front of the door trying to get something, and you press the remote, and the door's trying to shut on them.
Yeah. Number 3. No Power Rangers. I could watch pretty much anything else on kids' TV, but Power Rangers was not allowed. Not entirely sure why to this day, but knowing my mum, she probably just found the music irritating or thought it was too shouty or something. I must admit, I've never really got Power Rangers.
I never
really
got it
understood the
either.
appeal of it either.
No, I never got it.
I'm with Mum on that one.
Yeah, me too.
Yeah. We could have a lie-in on Sunday until about 10 a.m.-ish, but on Saturday we all had to wake up early. I don't know why, because it wasn't like we did anything different on that day. Yeah. I mean, yeah, we couldn't sleep in on Sunday because we were dragged out of bed and had to go to church.
Oh, no.
Oh, yeah. Yeah, I know. You had to get dressed into your finest Sunday clothes and roll off to church. And yeah. Yep. Saturdays, well, we usually had to get up reasonably early because we had to go and play junior tennis and stuff like that. So, yeah. All right, number 4. Dad must be the first to open and read the morning newspaper. If the pages had been separated already, he would refuse to read it.
Well, that's kind of a bit overboard, but yeah.
Yeah, I would have deliberately opened and separated the pages every single damn day. Be damned if he refused to read it. Well, that's his problem.
Yeah, my stepdad used to religiously go up to the newsagent and grab the Sunday papers, like the Herald, the Telegraph, or whatever they had, and bring them home.
Yeah.
And they'd sit on the dining room table, and I didn't touch them. But I just waited till he grabbed them so I could get the comics out of them. I said, you ready to read that yet, Dad? So I can get, because it had the Drive magazine as well with the car stuff in it. And,
yep. Yeah.
I used to want to get all that out of it.
Yeah.
I used to have a paper round delivering the papers to houses. I detested Sunday mornings because of all those bloody Sunday supplements. I mean, yeah. Especially when the tabloid ones started doing Sunday supplements as well.
Yeah.
God, it was a flipping nightmare.
Yeah. All right, next one. Only Dad was allowed to use a pint glass. The pint glasses. Yeah. Oh, well, I suppose you're not going to get drunk, are you?
How big's a pint?
I wasn't allowed.
Is that a schooner?
Yeah. Oh, I don't know. They don't call them that here. Yeah. I wasn't allowed to put on anything scented before bed, not even lotion on a cold night. I should go to bed scentless, or else my mum would get mad. I don't know why. Yeah. We didn't have any rules like that. My mum had a thing about The Simpsons. It was the only thing banned in our house. To be fair, it is an adult entertainment, and she was savvy enough to know that just because something is animated doesn't mean it's just for kids. Yeah, but I mean, of all the shows on TV, I mean, that, to ban it?
Who remembers number 96?
Yeah, I do. I remember sneaking around and peeking through the lounge room door to have a look.
What, the very first episode? I think from the very first episode onward, I think my mum probably told me I wasn't allowed to watch it.
Yeah.
What's that? Which one? Neighbours, Home and Away, or Grange Hill?
Nah, number 96. You probably don't know that one.
Don't know that one.
And Alvin Purple.
Mm-hmm.
Oh, yeah, mate. Those were
Yeah.
How else was a young person supposed to learn?
Yeah. Okay. My parents would let my siblings and me watch Aussie soaps like Neighbours and Home and Away, which were all the rage in the UK during the late 80s and early 90s, and all our friends ever spoke about. Even worse, they wouldn't let us watch a program called Grange Hill because it was inappropriate and unsuitable for children. But Grange Hill was a literal show for kids set in a school.
Yeah, right.
Yeah.
Yeah, I remember, I remember Neighbours and Home and Away starting, obviously, but I also remember Grange Hill starting, and it was on the BBC, and it was really controversial when it started in the mid-70s.
Yeah,
because it started.
I've never seen it.
It was about I would have said a north or northeastern London suburb secondary school. Okay.
We all used to sit down and watch the Sullivans.
And it was really, let's just say it displayed what life in a secondary school was actually like.
Okay.
Yeah, but we were forced to watch.
I remember the Sullivans too.
We were forced to watch those shows because that's what the parents wanted to watch. So we weren't allowed to watch anything we wanted to watch.
Oh, we didn't have to watch it. Like, if we wanted to, we didn't have to sit down and watch it. We could have gone and done something else, like read a book or, play a game or do some homework or whatever. We weren't forced to watch TV shows. Lol. Yeah. Anyway, next one. No drawing on the car windows with your finger, as your swiggles will stay there forever. It was quite the opposite in my family. Parents used to encourage us to and that sort of thing. Yeah. I don't know. We used to like when we were over at our cousin's place, we used to huff on the windows and then write rude words on the windows so that when they got in the car on a cold day and the windows fogged up, the rude words would appear. Yeah. No shaving allowed at all before I was 18. And I was like, why? Imagine that. You're not allowed to shave before you're 18. Like, you've got a beard and a moustache. And
No, not allowed to shave. No.
Not allowed to shave until you're 18.
Yeah, you have to keep that beard and moustache.
Yeah. Don't walk downstairs with glasses or socks on. Dangerous, apparently.
Yeah, if they're shiny treads,
upstairs to downstairs.
If the treads are shiny with socks on, it would be slippery.
Yeah, that was an animated picture, but it doesn't seem to be working for some reason.
Oh.
Doesn't matter. Yeah. I wasn't allowed to shower after 9 p.m, while my bedtime was 10:30 p.m. The only exception was when I was working in a store and I had to work until 9 p.m. What? So you turn into a gremlin or something?
Yeah. No, sorry, don't shower.
Yeah. Sometimes I used to get up in the middle of the night and have a shower because I was hot and sweaty, or, Yeah. No boys upstairs, not even allowed to put one foot on the bottom step. turned out that I'm a lesbian, so it wouldn't have been an issue anyway. Yeah. We weren't allowed to have blue Smarties, as my mum was convinced they contained heroin.
Oh.
They came out in the UK just as Grange Hill and EastEnders were dealing with drug storylines, and my mother read in a magazine that blue Smarties were laced with heroin. Might be a good time to mention that my mum is a doctor, so you would think she'd know better. It turns out that they did actually take blue Smarties off the market, but it was for a very good reason. It was because Nestle at the time were replacing all their food dyes with natural food dyes, not with artificial colorings. And the only color that they couldn't find a natural coloring for was blue. And so they had to withdraw the blue Smarties until they actually found a natural color, blue. But it's not quite as blue as what the old blue was, and you can see there in the image the old blue and the new blue Smarties. The new blue is a natural food coloring. Yeah.
Didn't know that.
That's terrible. Removing all the stuff that makes eating sweeties fun.
Yeah. All right. This is a different set of rules now. Rule: don't lick the toilet. I mean, I don't think we had to have a rule like that in our household.
Yeah, I think
no one would have even thought of doing that anyway. But
that's an unspoken rule.
I can't imagine a household where you have to have a rule of don't lick the toilet. I mean, yeah. Yeah. Don't pick up the cat and hold her like they do in The Lion King. She hates it and will scratch you.
Yeah. How did they pick the cat up in The Lion King?
You know how cats pick up their kittens by the scruff of the neck and they carry them around.
Yeah, you do that to a cat, they don't mind, or a dog.
Yeah, that's right. I mean, they don't like it when they're adults because they're heavy and big and it hurts. But,
but when they're a pup,
yeah, but when they're a kitten or something, that's how they get taken around. So, sure. Okay, please don't bite the badger. Like, I wouldn't even consider biting a badger anyway.
Yeah. Bite the badger?
Yeah. No eating candles.
Okay. Don't eat candles.
Yeah, I mean, some of the candles these days do smell really nice. I mean, they have all sorts of scents and odours that come out of them when you burn them and they smell like they'd be good to eat, but no,
okay.
I can't actually imagine myself eating one.
No.
Yeah. Yes, you have to wipe every time. No, that wouldn't be a rule I would have to have in my house. You just do it anyway. Don't eat any more coins.
Okay.
Kids are always gonna do that. They'll eat them. They'll put them up their nose. They'll stick them in their ears and all sorts of things.
Yeah. How many Smarties can I fit up my nose?
Yeah. How many toy army men can you fit up your nose?
Oh, toy army men, yeah.
You know? Yeah. How many marbles can you squeeze up there? Yeah.
Oh, it's ping pongs.
Yeah. We don't put crayons in our ears.
We don't? Okay.
No, apparently not.
Good advice.
Yeah. Keep your fingers out of the dog's butt.
Terry, have you seen who's just turned up in the chat?
Yeah, John Bernard, yeah. Hey, John.
Yeah.
Oh, ouch.
Well, the dog's
It's a
probably not.
fascinating
I don't know if the
button,
dog's complaining or not.
Yeah, fascinating button to press, eh?
Yeah, look what happens when I press this.
Yeah. Don't use scissors to try and unlock my door.
Okay.
You aren't allowed to pour hand sanitizer on a tissue and smoke it.
You're not? Why not?
No, apparently not. You know, like, damn it. I've always wanted to do that. No. I know there is a disease where some people actually put hand lotion on foam and eat it.
Ooh.
You know, like the foam bedding and stuff like that.
Yeah. Well, there is a person that's got a fetish for actually eating normal foam.
Yeah, there's a person that does that, and she puts pink hand lotion on the foam and eats it. Oh dear. Wood chips aren't food.
They're not. Well, throw a bit of cereal or milk on them and eat them for breakfast.
They got lots of fibre in them, apparently.
Yeah, keep you regular.
Yeah.
Crunchy.
Crunchy.
Yeah. Stop putting ketchup on your pancakes.
Why not?
Hey, I mean, if they're savoury pancakes, ketchup on them is fine.
And if it's the American ketchup, it's more sweeter than our tomato sauce. So
yeah. No, you can't take the fish out of its bowl and play with it.
But Mummy, I'm just taking the fish out for a walk.
Yeah. Oh dear. Stop trying to summon a demon. It was just a movie. Eat your food. Yeah. I remember a mate of mine told me his mum tried to convince him to eat food by saying, "Here comes the aeroplane." And he said straight back to her, "Aeroplane food tastes like shit." And she used to threaten him that she'd send it overseas to the starving kids in Ethiopia. And he said, "Go on, package it up then."
Not aeroplane jelly.
Yeah. Don't punch the cheese, eat the cheese.
Hey, that's a good one, mate.
Yeah. No, you can't glue the slug you found to a piece of paper. Oh, that sounds like a fun thing to do.
What sort of glue would work for a slug? Because they're slimy.
I don't know, but that picture that I found there is actually a slug that's undergone surgery, and they're using glue to stitch up its wounds after surgery.
They've actually done surgery on a slug. What?
Yeah, who would be bothered doing surgery on a slug?
Yeah.
I'm gonna guess it was some sort of test of microsurgery.
Maybe it could have been.
You know, to see if it works before you start moving on to larger things.
Oh, if I find a slug, it goes straight over into the chook yard, and the chooks.
Oh, the chooks loves things like
they love it.
And snails and stuff.
Yeah. Don't announce your farts.
What? What do you mean announce them? What? Make them loud or yell out that you did it?
No. Yeah, no. Yell out that you're going to do one.
Oh, okay.
Hey, everyone, I'm gonna fart.
Well, accidental farts.
Yeah, but you wouldn't announce it then, would you?
No.
That's right. Yeah. No, you cannot marry your sister. Who'd want to do that anyway? Yeah. Maybe if my sister looked like that.
In a TV show,
yeah. And that's all I had for you. With
that's
so
okay,
that was just
Paul. You've done well.
That was whipped up while Terry was arsing around trying to get his stream going.
Yeah.
Good on you, mate. Well done, mate.
All right. You want a quiz, I suppose?
Yes, please.
Yeah, it would be nice.
I do have a quiz.
Can I type in A?
One day I'm going to make a quiz with all the same answer for all 20 questions.
Now you tell us. Yeah, but
No, tonight isn't the night.
No, okay. Yeah, but how long would it take? How many questions did it take for us to figure out that they're all the same answer?
Right, I've just got to get the chat up. That's got that. And
So for anyone out in the peanut gallery that's not sure, just type your answer with the... Is there going to be a numbered question and then an answer after that? Yeah. Yep. It should be. Something like that.
Make sure I've got everyone on the internal chat.
And Alan, make sure you've got everyone in the internal chat.
And I'm making sure I'm in the internal chat after Surf tried to trick me into being in the...
Oh, did Surf try to do you?
Tried to trick me into being in the outside chat by getting me to reply to a message.
Yeah, okay. I think they know you well for that one, Alan.
Yeah.
All right. So, as usual, the quiz has got a smattering of physics, chemistry, astronomy, geology, biology in it. It's got a mixture of multiple choice and straight answer questions. There's a clue usually. Sometimes the clues are useful, sometimes they're not. All right, here we go. Question 1. As a 10-kilogram mass on the end of a spring passes through its equilibrium position, the kinetic energy of the mass is 20 joules. The speed of the mass is what? And for those of you that don't know how to figure this out, there's an equation that you can use to calculate kinetic energy. So I'll give you that equation. There it is. Kinetic energy equals half times the mass times the velocity squared. You have all of those quantities except one. You should be able to put it in and rearrange the equation to get the velocity. Let's see how good you are at doing that. Jinx uses all of the subjects I struggle with. Well, if you discount biology, chemistry, physics, geology and astronomy, it doesn't leave much else. I guess it's computer science. Mechanics, like cars and shit. Okay, we've got some answers out in the peanuts. Got no answers internally yet. Come on, guys.
Come on, Alan. I can't cheat if you don't type an answer.
I need my triangle calculator.
Yeah, sorry, I struggled doing the equation in my head.
Oh, okay. Okay.
Math,
all right.
I keep saying, I always struggle with the maths. I can do it, but I have to take my time and write it all down properly normally.
Yeah,
oh, okay.
So on the left-hand side, we have kinetic energy, which we know from the question is 20. Moving the half across from the other side, you double that to 40. And divide by the mass to eliminate that from the right-hand side. The mass is 10, so 40 divided by 10 is 4. What squared equals 4? That would be 2. So the answer is 2 meters per second.
Okay.
Which was answer number A. Well done, all those that got A out in the peanuts. There were quite a few of them. There were a few that got wrong ones too.
Surfy.
Yeah. 3. It's easy. All right, there you go. That's that one. All right, question 2. Well, do you know your Earth history? During which period in the Earth's history did most dinosaurs become extinct? Was it during the Carboniferous? Was it during the Cretaceous? Was it during the Quaternary? Or was it during the Triassic? Which period did most of the dinosaurs become extinct?
I'll try that one. That's the only one I can recognise. I know it's not that one and that one. So this leaves two. I'm confused with the two, but I'll do that one. Yeah, that's the one I was thinking of, Fondle.
I'll give you 10 or 15 more seconds and then I'll put up
The clue.
a hint.
Yeah, I know. I always forget. I always forget the clue. I can check to see if I'm wrong or not now.
Yeah, we've got some correct answers. Or we've got a correct answer out in the peanuts.
Yeah, they're not waiting for the clue. They're not waiting for the clue either.
There's the clue.
Brainery's waiting for the clue. Okay. Okay.
You get it now, Terry?
Yes, I'm wrong.
Yeah.
I knew I should have went.
Well, the clue is, Surf. The clue is the answer is D. No, it's not. And as you can see by the diagram, the Cretaceous is the period that the dinosaurs peaked at and also became extinct.
Yeah, I was confused between Triassic, but that's the first dinosaurs. Not
Yeah.
Yes, the KT boundary is 67 million years ago when a big thing fell out of the sky and landed sort of just near the Yucatan Peninsula.
Yeah, hypothetically supported with a fair bit of evidence.
Yeah.
What, like finding the crater?
Yeah. Oh, that's just happened to be a crater there.
Well,
yeah. So the answer was
an impact crater that was just the right age.
Yeah.
along with all that iridium that shouldn't be there.
Yeah.
In the geological column.
Well, look out.
Question 3.
We've got Big Blue.
Yeah.
He's gonna.
All right. Question 3. According to Kepler's laws, the cube of the mean distance of a planet from the sun is proportional to the what? Is it proportional to the area that is swept out? Is it proportional to the cube of the period? Is it proportional to the square of the period? Or is it proportional to the fourth power of the mean distance?
I've heard of Kepler. Does that help?
Yeah. I'll give the clue a little bit earlier in this one. You can browse the clue.
Yeah. I'm seeing that word. Okay. If I'm reading that correctly...
Give you a hint.
Yeah,
give you a hint. The writing that's in green gives you the answer.
Yeah, I know. That's what I was just going to say. Going by what I'm reading in there, if that matches there...
Yeah. All of the equations tell you this as well, but pretty clearly the writing says that Kepler's third law says that the square of the period of a planet is directly proportional to the cube of the semi-major axis of its orbit. Okay, so it's the square of the period. It is answer C.
Did Blue get that
wrong?
Well
done. Yeah.
Didn't you get the clue, Blue?
Wrong.
You read it wrong, yeah.
Yeah, I just joined and I read it wrong.
All right, well, you can redeem yourself now. Okay. Question 4. Which of the following scientists hypothesized that it would be possible for particles to have wave-like properties? Was it Planck, Heisenberg, Einstein, or de Broglie?
Possible for particles to have wave-like properties. This seems very familiar for some reason.
Surf says, I'm colourblind. Your hint is discriminatory. The green writing was just about the only writing. All the rest was equations anyway.
No, you're not colourblind, Surf. That's being, I reckon you should say colour literate, because that's what I prefer to use, that term.
Yeah. Well, we've got a spattering of answers out in the peanuts.
I'm waiting for the C word.
Oh, the clue word.
Here we go. Trying to read the writing. I wonder if it's that guy. That guy, yeah, that guy.
Which guy? That guy.
No, that guy.
Yeah.
That guy.
The guy that's been mentioned a few times in the clue.
Yes, maybe.
It of course
that guy. That was too easy. That guy.
It was de Broglie.
Yeah.
He was the one that hypothesized that particles also had wave-like behaviour. And then they tested it.
Yeah, like photons and stuff.
Well, no, like electrons. Electrons can exhibit wave-like behaviour. We think of electrons as particles, but they can exhibit wave-like behaviour, and we use that wave-like behaviour in electron microscopes.
Yeah, that's
because the wavelength is very much smaller than the wavelength of light. Yeah.
Yeah, that electron microscope thing. I knew there was something familiar about something.
Yeah.
All matter exhibits wave-like behaviour. It's just that usually the wavelength is just so long.
Yeah.
It kind of doesn't really.
Yeah.
Make a lot of difference.
Yeah. Question 5. Many living organisms exhibit the unique property of producing visible light. What term is used to describe this phenomena? Yeah, looks like we're right on to this one. Everyone's got the bioluminescence. Does anyone know another word that can be used for it that starts with P?
I need a... I know what the word is, but... P or B? P.
P.
P. Yeah. I know it's... I don't know how to spell it.
Yeah, it wasn't phosphorescence that I was thinking of, because phosphorescence is more of a chemical. I mean, bioluminescence is chemical in nature too, but the word I was thinking of was photoluminescence. Okay. So, but well done for getting bioluminescence, everyone. That was good.
Yeah, I know. I went with what Blue... I didn't cheat Blue. I was thinking of the same thing Blue said.
Yep. Okay, question 6. As a longitudinal wave moves through a medium, the particles of the medium do what? Do they vibrate in a path parallel to the path of the wave? Do they vibrate in a path perpendicular to the path of a wave? Do they follow the wave along its entire length, or do they not move at all? So think about an individual particle as a longitudinal wave moves through a medium. So here's an example, a little GIF showing a example of a longitudinal wave. And you'll see a couple of particles highlighted in red there. If you follow the motion of those particles, you will see that they vibrate backwards and forwards in the direction that the wave is travelling. And that's why they call it a longitudinal wave, because the answer is A.
Ah. Oh, sorry, I missed out on that one.
Okay.
You're used to dealing with transverse ones.
Yeah. Okay, question 7. How well do you know your map symbols? On a topographic map, lines that indicate water depth are termed what? Are they called isogonic lines? Are they called bathymetric lines? Are they called isopachs? Or are they none of those?
Is this a topographical flat map or a topographical globe map?
Doesn't matter. Either one, the water's still going to have depth.
Yeah. I don't know. I'm not too sure. Oh, we got a clue. Shit, I forgot about the clue.
Yeah. The clue would have helped you, Terry.
Yes, and I was going to pick that one because of the word. That word helped.
Yeah.
Yes. If anyone picked that one,
do you know what
yeah.
Have you ever heard of a bathysphere, Terry?
No.
A bathysphere was like a sphere that divers could get into. Now, they put their head in the sphere, the bathysphere, and descend. Okay?
Yeah.
So it's got to do with water. So anything with bath or bath in front of it has something to do with water. Okay? So the correct answer was they are bathymetric lines.
Yeah.
Yeah.
Oh, they picked that out. Ozzie and Jinx got it.
Yeah. Yeah. Okay, next question. Question 8. What type of visible star is the coolest? Okay, there are more types of stars than those, but out of those listed there, type O, type A, type G, or type M, which are the coolest stars of those 4? And by cool, I don't mean He-Man. That's really cool.
That's what I
mean, like cool as in temperature-wise.
Yeah. You guessing, John, without the clue?
I knew that one, mate.
You know that one?
Knew it, John?
Oh.
Let's have a look.
Yep.
Oh.
We've got a budding astronomer out in the peanuts. So I'll give you a table to look things up in.
Well, going by that,
Mm-hmm.
If that's correct,
that would be right, Terry. Because as you can see from that table, M-type is at the bottom of that list, and they have the coldest temperatures, 2,000 to 3,500 degrees.
Oh, really? Oh, bugger.
And,
Yep.
and I guess we're orbiting a G-type star then.
We are a G-type star, yes.
Oh.
Yep.
Oh, bloody
Yep.
hell.
So the correct answer was M-type stars.
Hey, John.
Yeah.
You didn't know that one, John.
No.
Yeah. Question 9. Who developed the equation that is used to determine the probability of finding the electron in any given place? Come on, you all know this one, but do you know how to spell it?
Oh, that's a clue in itself.
Oh, God.
Right, to determine the probability of finding the electron in any given place.
I was thinking of the other bloke.
Well, you type which one you think of then, Terry. You just might be correct.
I don't know how to spell it though. I'm not sure how to spell it.
Spell it any way you think, Terry. I'll know whether you're right or wrong, even if it's misspelled.
Yeah, I misspelled it.
Yeah, I think I can get who you mean, though. Kind of.
It's supposed to have a G in there somewhere too.
Yeah. So there's the clue.
Yeah, I got it right then, even though I spelt it wrong.
Yeah. I see some people put Heisenberg. Heisenberg was the bloke that he postulated the uncertainty principle, not the probability equation that basically outlines the orbits of electrons and stuff. Yeah. It was Schrödinger. Yeah. Schrödinger's equation. Yeah.
Hey, I'm remembering things for some reason, somehow. I don't know.
For some reason.
Yeah, for some
Maybe
reason.
it's because you got a brain.
Okay.
Yeah. Question 10. Surplus red blood cells needed to meet an emergency are mainly stored in what organ of the human body? Is it the pancreas, the spleen, the liver, or the kidneys?
Really? I didn't know that. I can't hazard
Red blood
guess.
cells are, of course, manufactured in the bone marrow, but the body has a store in reserve for in case there are emergencies.
Wow.
And they're stored in one of these 4 places, mostly.
I'll wait for a clue.
Okay.
Who's guessing out there in here? They're guessing that one and that one already. I'm waiting for Blue. Or is Blue waiting for a clue? Scott's guessing.
We've got almost every answer except A out in the peanuts.
No, there's someone in here. Let's pick the A.
Okay. The liver is the reddest organ. Yeah. Well, I'll give you the clue and then you'll know the answer.
Okay.
Bloody hell.
So
there you go. So amongst amongst other functions, one of the functions that the spleen has is acts as a reservoir of blood in times of shock or hemorrhage.
Wow.
There you go. I didn't know that until I found this question. So there you go.
Yeah, I wouldn't have known.
All right, so it's the spleen, obviously.
Yeah.
Question 11. As a pendulum is raised to higher altitudes, its period would do what? The period is the time it takes to swing backwards and forwards.
Yeah, I knew that.
So would the period increase, decrease, remain the same, or decrease and then remain the same?
I've got a theory, but I can't work out the answer to the theory.
Okay, well, I'll give you a clue then. The clue here is that's the equation for the period of a pendulum. T. T is the period, and it gives you the equation there to work out what the period of the pendulum will be. And you can see that it's got a 2 and a pi there. They're constants, they don't change. And then it's the square root of L on G, where L is the length of the pendulum and G is the acceleration due to gravity. So given that if you're raising it to altitude, you're not changing the length of the pendulum, the only thing you're doing is changing the G. And if you go up in altitude, what are you doing to the G? Making it bigger or smaller?
I know you're making.
Oh, yeah.
I know you're making it. I know you're making it one, or the of the two choices. But how would that? Well, I'll just have to put that answer because that's. Oh, wait a minute. Yeah, that one.
Okay.
I'm thinking it's.
So looking at that looking at that equation, you can see that the only thing it's going to rely on, the only thing we're changing is the G, the value of G, and as you gain altitude, the value of G will decrease. Remember, G drops off in an inverse square relationship as you go further away from the planet. So if G decreases, it's on the bottom of that fraction. You make the bottom number of a fraction smaller, you make the fraction is actually bigger. And so the square root will be a bigger number, meaning that the period is bigger, it increases. And it makes sense because if you're using less force to drag that pendulum down, it will take longer to swing. Okay, so the period increases. D was kind of like a tricky one there, because yes, the period will increase and then remain the same. It won't decrease though; it'll increase. Okay, so it was A. It increases. Question 12. In geological studies, a fault in the Earth's surface in which the hanging wall has moved up relative to the footwall is termed what? Is it called an overthrust fault, a reverse fault, a tear fault, or none above? So quite often you'll have, like, when you have a fault line, there are a number of things that can happen. The two plates can, or the two portions can slide past each other, and you'll see that where a road suddenly ends and it starts about 2 meters to the left again, or something like that. Or you can have a change in level where one part will drop below another part, and if that fault line is at an angle, sometimes the bit that's raised up will overhang the bit that's lowered down, and that is known as a what? Here's a little GIF that shows you how that works.
Oh, it's called that.
Okay. Yeah.
I was thinking of it in the first, what I thought put there.
If it goes the other way, if that bit slides down, then it's just a normal fault. So the answer was that it is a reverse fault. Question 13. Which type of star is maintained by the pressure of an electron gas? Is it a main sequence star, a white dwarf, a neutron star, or a black hole? Okay, so we know that in most stars, like our sun, for instance, that the size of the star depends on primarily two forces. The force of its own gravitational attraction, trying to compress it down to a smaller ball, and the heat pressure. So the pressure pushing outwards, trying to expand it. And so they reach an equilibrium, which determines the size of the star. But in this kind of star, it's the actual electron gas that maintains the pressure, stopping it from collapsing further. Which kind of star is it? Is it a main sequence star? Is it a white dwarf, a neutron star, or a black hole?
So where's the ether?
yeah. I don't think ether supports any stars. Yeah. And if you have a little bit of a read of that, you'll see that there's a point there that says that the pressure of a degenerate electron gas at high densities supports the objects with no fusion, dead stars, white dwarfs, and the ones of giant planets, Jupiter and Saturn. Okay, and right down the bottom left-hand corner, it says white dwarf, electrons run out of room to move around. Electrons prevent further collapse. Protons and neutrons still free to move around, but the electron gas causes a pressure which supports them. So the answer was B, white dwarfs.
Bloody hell.
Did you get that one right, John?
No.
Ah.
And then me thinking, yeah, you finally got one right.
Oh.
Yeah. Question 13. Which type of star... Oh, hang on. That's better. Question 14 we're up to, yeah. What is the pH of a solution that is 1,000 times more acidic than pure water?
Phew, crikey.
This is testing your knowledge of what the pH scale is actually all about. What does a pH of 7 mean? What does a pH of 6 mean? 5, etc.
Phew. I don't have a clue.
Surf went one way and Vroom Fondle went the other way. One of them is correct. Yeah, there's the clue. Okay, the clue in the diagram is the words right at the bottom in the center where it says that the pH is the negative of the log to base 10 of the hydrogen ion concentration. And what that little log tells you is that it's a logarithmic scale. The pH scale is a logarithmic scale, and because it's based on log to base 10, it means that a decrease of 1 in the pH scale means it's 10 times more acidic. So a decrease in 2 on the pH scale would mean it's 10 times 10, which is 100 times more acidic. So for something to be 1,000 times more acidic, it has to be 10 times 10 times 10, which is 3 lots of 10. So you take 3 from 7 to get 4. The answer is 4, because 4 lower than 7 is the acidic side of the pH scale.
Oh,
above 7 is is the basic side of the pH scale. Okay. All right. Question 15. When a human donor gives a pint of blood, it usually requires how many weeks for the body's reserve of red corpuscles to be replaced? Is it 1 week, 3 weeks, 7 weeks, or 21 weeks? So you give blood, of course, you've given away a lot of your red blood platelets. How long does it take your body to replace those back to normal? Is what this question is asking. There's your clue. And the clue is in point number 4. It turns out that it takes the body around about 7 weeks. All right. 7 weeks to replace those red blood cells. Well done, Terry. Okay. The volume is replaced fairly quickly, but not the actual platelet count. Okay. The SI unit, here's an easy one for you. The SI unit of pressure is the what? Is it the torr, the dyne per centimetre squared, the atmosphere, or is it the Pascal? And yes, all of those are units of pressure, but only one of them is the standard international unit of pressure. Yeah, I'm sneaking 4 into the questions. I should be banned, shouldn't I? Yeah, the peanuts mostly know this one. Those are also units of pressure used in various countries around the world. But the very top one, the Pascal, is the international, the standard unit of pressure. The Pascal. Newtons per square metre. Okay. Question 17. What is the name given to a flat-topped plateau bordered on all sides by cliffs? You get a picture to see what one looks like. What are they called?
Oh,
There's 2 words that can be used for it.
Yep. I know there's one word, but there's another word. I thought there was another word. No, I didn't copy your blue. I had that in my head. Now 3 of us have got it right in here.
Yeah, we've got some correct answers out in the peanuts too. One name you can call it is, of course, a mesa.
Yeah.
But does anyone know the other word that's often used for it as well?
That's the one I couldn't think of.
I like big, and I cannot lie. The other word is but, with an E on the end.
Really? Okay.
Yeah. Yeah.
I didn't know that one.
Yeah. But I think Misa is more
Yeah.
commonly used for them. Yeah. Yeah.
Ancient tree.
Okay,
So
question. Yeah. Question 18. Io, Europa, Ganymede, and Callisto are satellites of what planet? Is it Jupiter, Saturn, Neptune, or Uranus?
Oh, God, I should know this.
You should, John. This is an easy
Oh,
one.
Yeah.
I did a video. Mind blank.
I think I might actually have photos of them going to come up in my thingy thing in a minute.
Oh, you Duvalaki? Your what's his name?
The camera
Thingamabob.
thing. My thingamabob. I might even hit the pause button when it get. I might even hit the pause button when the pictures get here.
Yeah.
Oh, bloody hell. Brain's not working right.
Saturn's got rings.
Bad peanuts. There's some good peanuts out there, but
There you go, Paul. Picture of them.
Well, I can't see it at the moment anyway because I haven't got the
Yes. Yeah, we've got
the Zoom thing open. Yeah. Yeah, everyone in the internal chat got it right, but I think the peanuts need a bit of educating. There you go. There's a list of some of the moons. Not all of them, because there are quite a few moons in the solar system. These are just the biggest ones. And you'll see listed under Jupiter there, Io, Europa, Ganymede, and Callisto. All right.
And it's got some other
So it
ones
was Jupiter.
too.
Yeah, there are others. Can't remember how many Jupiter's got now. It must be getting into the hundreds.
Wow, that's a lot.
Yeah.
Not as many as Saturn, though, is it?
Question 19. The rate at which dissolution occurs is least dependent upon which of the following factors? Temperature, pressure, solution concentration, or solute surface area. So they're talking about how fast something will dissolve. What will affect it most and which won't affect it. So you're being asked in this question, what won't affect that process much?
Right, okay. Yep.
I reckon that one. Oh shit, I've got to wait for the clue. I'll wait till the clue. Did you go for the same as me, Alma?
And blue.
And blue. Oh, blue went for it too. Yeah, I was thinking that one.
Blue made a mistake and corrected it.
Oh. Well, we could take your first answer. You didn't put a line through
if
it.
you do that, if you take the first answer, I'm wrong.
Okay.
There you go. Factors that affect the rate of solubility.
Oh, there's two of them there. So could we have answered two of them?
Huh?
Because of the bottom.
No. The question is asking which one least affects it, Terry. Which one doesn't affect it very much?
Oh. I answered wrong. I think I might have answered wrong.
Yeah. Increasing the temperature will make things dissolve more. Increasing the concentration of the solvent usually makes it dissolve faster. Increasing the surface area of the thing that you're dissolving usually makes it dissolve faster too. Like if you grind your salt up really fine, it won't take long to dissolve in the water at all. But if you put a great big thumping lump of rock salt in there, it's going to take a bit more stirring to dissolve it. Okay? The only thing that really doesn't affect that process much is pressure. It does affect it when it comes to gases because, of course, with gases, if you compress them, then the molecules are closer together and more likely to react. So that will affect gases, but normal things like solids dissolving in liquids, pressure doesn't really have much effect at all. So the thing that's least likely to affect it is pressure.
I got it right for the wrong reasons again, Paul.
Okay. What was your reasoning, Terry?
I was thinking pressure affected it, not the other way. It didn't affect
it. Okay. Yeah. All right.
But just not very much.
Yeah. All right. Question 20.
Yeah.
Okay. When a wound occurs in humans, the platelets in the blood activate a substance which starts the clotting process. The substance which starts the clotting is what? Is it adenosine? Is it histamine? Is it lecithin? Or is it thrombin? If you think about this, you'll know the answer. Think about what a blood clot in your leg is called.
I've heard of one of those words.
Yeah, which one have you heard of, Terry?
B.
Histamine. Have you heard of an antihistamine?
Mm-hmm. Yeah, I've heard of antihistamine.
What do you take those for? Yeah. Do you know what you use them for?
No.
Oh, okay. I'll give you a hint. Antihistamines are used to prevent allergic reactions. Like swelling, things like, bee stings, hay fever. Easy clue. Which basically gives you the answer.
Well, I'll go for that one then.
Yeah.
And that is not a list of things you want to have happen to you, is it?
No, you don't want that to happen to you, because that can be very dangerous. Because if you've got a DVT or a deep vein thrombosis in your leg, in a vein or an artery in your leg, that can dislodge and move up into your lungs and kill you, or cause a stroke.
Yeah, well, I was looking at the list that finished with which finishes with myocardial infarction, because that would kill you as well.
Yeah. So the answer, of course, is thrombin. Thrombin is the substance which starts the clotting process. Yeah. There you go.
Yeah.
That was the quiz, folks.
Yeah.
So either give yourself a pat on the back for getting all the answers correct, or give yourself a pat on the back for learning something.
Well, I can give myself 2 pats then.
It's good, mate.
Yeah.
I was going to say, I like no-nos. I must be allergic to biscuits because they make me swell up.
Yeah, right. If you eat too many of them consistently. Yeah. There you go. That was the quiz. All right.
I'm allergic to beer because it makes me feel dizzy.
As usual, I will transfer that across to my Google Drive and put it in there somewhere. Give me a minute or two to do that.
While you're doing that, we'll finish off with the Pip story for the night, and bid you all adieu after that. Where are we?
Good night, Jinzu.
Jinxu's gone. Okay, good night, Jinxu.
He's going to bed.
Yeah. Oh, then you can go to sleep on the story, because we're finished now. I don't know which one this is of Pip's. It looks like it was made a couple of episodes back. What's it called? The Thistle and the Fairy Flag of Dunvegan.
The Scottish Thistle. The Thistle of Scotland is said to be the oldest national flower on record. The legend of how this proud and regal plant became a national emblem goes back many hundreds of years to the time when Scotland was being rampaged by the vicious Vikings. From 795, Scotland was under assault by wave upon wave of vicious Vikings. It was a frightening time to live in. Scotland was vulnerable to attack, its delicate civilization built by generations of Christian monks. For hundreds of years, much of Scotland was part of the Kingdom of Norway. Even after Norway became Christianised, the attacks continued. Not until 1266 was the Western Isles returned to Scottish rule. By 1263, however, Norway seems to have had little interest in their former territory. That was until King Alexander III proposed to buy back the Western Isles and Kintyre from the Norse king Haakon IV. The thought of relieving King Alexander of some of his riches and territories appears to have rekindled Norse interest in Scotland. Late in the summer of 1263, King Haakon of Norway, now intent on conquering the Scots, set off with a sizable fleet of longships for the Scottish coast. Gales and fierce storms forced some of the ships onto the beach at Largs in Ayrshire, and a Norwegian force was landed. Legend has it that at some point during the invasion, the Norsemen tried to surprise the sleeping Scottish clansmen. In order to move more stealthily under the cover of darkness, the Norsemen removed their footwear. But as they crept barefoot, they came across an area of ground covered in thistles, and one of Haakon's men unfortunately stood on one and shrieked out in pain, thus alerting the clansmen to the advancing Norsemen. His shout warned the Scots, who defeated the Norsemen at the Battle of Largs, thus saving Scotland from invasion. The important role that the thistle had played was recognised, and so was chosen as Scotland's national emblem. Haakon died returning to Norway. A treaty returned the Hebrides to Scottish rule, and a marriage contract wedded Scotland and Norway. Another version of this legend attributes the legendary King Achius with the appropriation of the thistle. This king is said to have founded the Order of the Thistle in the 9th century, limiting the number of knights to 13, including himself. Unfortunately, this story is yet to be proved, but there is definitely an Order of the Knights of the Thistle, which commenced or was refounded by James VII in 1687. The Order has a checkered history, but today is firmly anchored in St Giles Cathedral, Edinburgh. The Knights have the motto, Nemo me impune lacessit, which translates as no one assails me with impunity, but is more commonly read as Hodor meddle wi' me. This motto is also used by Scotland as a nation, and, thinking of the spiny prickles of the thistle, could hardly be bettered. The Fairy Flag of Dunvegan. One of the most treasured possessions of the Clan MacLeod is the famous Fairy Flag of Dunvegan. The story behind the flag is one of the greatest romantic tales in all the Highlands. A great young chief of the Clan MacLeod fell in love with a fairy princess, a Bean She, one of the Shining Folk. The pair were determined to marry, but the king of the fairies forbade the union. Such was the young fairy princess's distress that he finally relented and agreed to a period of hand fasting. This was a form of trial marriage which traditionally would last for a year and a day, and was common in the Highlands at the time. However, the king demanded that at the end of the hand fasting, the princess must return to her own folk and take nothing human with her. The couple lived in harmony, and soon a young son was born to them. Alas, the time sped by, and soon the hand fasting was over. The couple parted with great sorrow at the famous fairy bridge, and the princess returned to the fairy kingdom. As she left, she made her husband, the chief, promise that her son would be cared for well and never allowed to cry, for the sound of his cries would cause her untold grief, even in the faraway fairy realm. The chief kept his promise, and the young MacLeod was never left unattended and never allowed to cry. However, the young chief grieved terribly for the loss of his wife, and the other clansfolk decided that they should organise a great party in the castle of Dunvegan on the occasion of his birthday, to take his mind away from his grief. The birthday celebration ran long into the night with high spirits, and the young nursemaid assigned to watch over the infant crept from the room to watch the revelries. As she watched, enraptured by the celebrations, she did not hear the baby kick off his covers and begin to cry. The child's mother heard the cries from her fairy realm, and suddenly she appeared by his side. She took up the young baby and cradled him back to sleep, covering him in a fairy shawl. She sang to the child and was still singing when the maid returned. The maid could hear the lullaby, but not see where it was coming from. She immediately took the baby with the shawl she did not recognise to the chief and told him what had happened. Many years later, when the child grew into a young man, he recounted a tale to his father that the shawl was a great talisman for the clan, and that should they ever find themselves in mortal danger, they could wave the flag 3 times and the fairy legions would come to their aid. However, this talisman could only be used 3 times, whereupon it would return to where it had come from, taking the flag waver with it. The chief instantly realised the young man was telling the truth, and the flag was kept safe. The flag has since been used twice, once when the MacLeods were vastly outnumbered by their bitter enemies, the MacDonalds. The chief took the flag from its case and waved it 3 times, at which point the battle suddenly turned in favour of the MacLeods. A second time, the land was blighted by a plague on the cattle, and the clan kinsmen were dying of starvation. The chief again raised the flag, and the fairies returned to bring the cattle back to life. This may seem like a fanciful tale, but many MacLeods believe wholeheartedly in the legend. So much so that during World War II, many MacLeod servicemen carried a picture of the flag in their wallets. It is said that of the MacLeod airmen who defended these shores during the Battle of Britain, not one who carried the picture was lost, and indeed the chief of the clan offered to bring the flag to Dover to wave at the Germans should they attempt to invade. The flag can still be seen in Dunvegan Castle on Skye. The end. Don't forget to like and subscribe and press the wee bell notification. And a huge big thank you to all my subscribers and patrons. See you next week. Bye bye.
Bye. Oh, there you go. That's your lot for tonight. Anybody want to, any last words? Nothing?
No, I've got the rest of my life to say words. I'm not saying last words now. Are you threatening me, Terry?
Yeah, your last words. Yeah, that's it. For speak now or forever hold your, whatever it is.
Just good night, peanuts.
Yeah.
It's a good night for me and a good night for him.
Good night.
Yeah. Good night.
Yeah, no special peanut. Sorry.
No,
Macadamias.
I'm running out. It's too hard to do that.
Okay, panel. Thanks, Leonardo Bonacci. Did I say that wrong?
Bonacci.
Thanks, Alan. Thanks, John. Thanks, Big Blue. Thanks, Scott. Couldn't get a word in sideways with Scott. Surf, Fondle,
Yeah, tend to talk a lot.
No name. Boggs out there. Who else? Surf. Ozzie, NRG, Jinxu, Brainry. Who didn't? Oh, no name yet. Did I get enough likes out of yous? I don't know. I'll have to check. What did?
Funny, yeah,
Were yous
I forgot to
all
like
out
this
there?
one because I'd
Well,
already
30
liked the
watching
other
and
one,
17 likes. I think somebody's missed out. Okay,
There
who
you
missed
go.
out? Who missed out on the thumbs up before I go?
I did, because I'd forgotten that we'd changed stream, because I'd already liked the old
Oh,
one.
you liked the other one. Oh, so who missed out? Oh, that's 20. So
Alan, Surf wants you to say Googly Elmo again.
No.
Hey, Googly Elmo, is that like 10 to the power of 100 Elmos?
Yeah, there's a lot of Elmos.
Yeah.
There's a lot of Elmos.
Good job I wasn't drinking them, Paul.
I'll see you over in Discord, anyone that wants to join.